Okay, Algebra 1, guys, I hope you're ready. Exponential decay functions. You know what? It's not much different than yesterday. We were talking about exponential growth functions. But now things are going to go down. Sometimes they go down exponentially, like the value of your car. Or, I don't know, we talk a lot about values of things depreciating. Okay, so I'm going to leave it at that for now. But a couple of things I want to talk about. Yesterday, we said that the exponential growth function is y equals c times 1 plus the rate to the t. So if I'm adding the rate, you know that the stuff that's inside the parentheses here is going to be more than 1. All right? Now today, we're actually going to talk about decay. And so we use a formula. It's very similar. It's just 1 minus the rate to the t. Okay? So, I mean, it's very simple, but think about what it's doing. It's making the amount that's inside the parentheses less than 1. And anytime I multiply a number by a number that's less than 1, it gets smaller. Okay? So when I raise something to the t, I'm just going to write it a little bit bigger. I know that's a little fuzzy. 1 minus r to the t. Anytime I multiply this number anytime I do that repeatedly, I raise it to the exponent of t, it's going to be getting smaller and smaller and smaller. So I can look at a function and tell immediately whether or not it's growth or decay. You can do that just by saying, you know what? The stuff inside the parentheses is less than 1, so it's decay. Or the stuff inside the parentheses is more than 1, and it's going to be a growth function. Okay? So today we're going to be talking about some things that are decaying over time. And I should have thrown something in here like the half-life. There are a lot of good problems that talk about the half-life of carbon-14, for instance, to tell. It's a test that we can use, or scientists use, to determine how old something is by how much carbon-14 is still left in the organic or in the carbon-based body after it dies. Okay, so that's something to think about and look for. Okay. There's not a lot that I need to talk about here. It's just a different formula. But let's see how this works out in some of the problems. Okay? See you at example 1.